Alright, so in this video we're going to talk about solving equations and inequalities, including multivariable forms. So I'm pretty sure you've solved equations and inequalities in your previous algebra class or classes, so I'm just going to hopefully jog your memory. So there's one very nice, clean idea that pretty much summarizes the whole notion of solving equations. And that idea is that you have to keep both sides equal to the same value. Okay? You have expressions on each side, and when we evaluate them, evaluating, remember, that means replacing the variable with a certain value. Okay, so that we have to have the same thing on both sides, right? So hold that, put that equation aside for a second. If I had a number, I'm sure you would agree that that number is equal to itself, right? Now watch this. If suppose I added 1 to both sides, okay, 5 is equal to 5. All right, now suppose I doubled both sides of 5 and 5. So 10 is equal to 10. And let's add 2 to each. Now let's take away 4. So if I subtracted 4 from each side, it would still be equal. And then if I chopped each side in half, I would get 3 on both sides. So the point is, I can, as long as I do the same thing to both sides, the expressions on both sides still remain equal. The values that they evaluate to. Okay, so that simple, wonderful idea is how we solve all algebra equations. Okay, we simply shuffle things around. We simply add, subtract, multiply, and divide stuff from both sides until it's obvious what the answer is. So here, and you can not only move numbers around, you could move variables around. So watch. I'm going to subtract 4 from both sides. All right. Now I've already done that in the when I went from 10 equals 10 to 6 equals 6. So that's gonna, the same way it worked there, it's gonna work here where I have unknown numbers with variables. Okay. Now I can also subtract the unknown value as long as I subtract it from both sides. So let's subtract x from both sides. Okay, we might not know what the value is, but as long as we take whatever it is from both sides, it's still going to be balanced. Okay, so then we clean everything up. So on the right side, the 4's kill each other. On the left side, the x's kill each other. On the right side, 2x minus x. On the left side, 1 minus 4. So now it should be obvious what the answer is. X is equal to 3. Okay, I can write it the other way if you like. And then if you're ever unsure whether you solved it correctly, like for an exam, go ahead and actually try evaluating the original expression. Okay, that is practically a guarantee of the fact that if that works, it's almost a guarantee that you got everything right. So watch this. Let me go back to the original black equation, and I'm going to replace the x with a 3 everywhere. Excuse me, I'm going to replace it with a minus 3. Thought something was fishy. Okay, so on the left side, minus 3 plus 1 gives minus 2. On the right side, minus 6 plus 4 is minus 2. So lo and behold, both sides are the same. Okay? Now, inequalities have the wonderful property that for the most part it's the same notion, the same skills allow you to solve inequalities. Okay, so let me do an example, and then notice I said for the most part, so there is going to be a gotcha that we have to be aware of. So suppose we had this inequality. Okay, so what I would do is like I did for equations, and for the most part you can just do what you did with equations. So I would Let's see, let's add x to both sides and let's subtract 10 from both sides. Then let's see what blows themselves up. Now, by the way, if you're wondering what do you add and subtract from both sides, it's because you love it when things blow up. Okay, we want things to blow up because that makes things simple. Okay, that's how you select what to add and subtract. All right, so now that we got that clear, on the right side we have 4x, on the left side minus 3. Divide both sides by 4. You can not flip it, but you can write it in an equivalent way with the letter in front, the variable in front if you like. Okay, and so that's the answer. Again, if you want to check, go ahead and plug a value from that satisfies that inequality and see if it works. So what is a value that is less than negative 3/4? Well, how about minus 1? That's less than minus 1 is less than minus 0.75. All right, so I'm going to plug that in. So into the original blue. So 7 minus minus 1, is that greater than or equal to 3 times minus 1 plus 10? So on the left side I get an 8, and then on the other side I get minus 3 plus 10. So that says x is greater than or equal to 7, which check, that's true. Now you might want to plug in more than one value to make sure. You might also want to make sure that if it doesn't satisfy your answer, that it's not true. That would be even safer. So for example, a nice value to work with that is not less than 3/4 is 0. Okay, so now I'm going to plug in 0, and I want it to not work. Okay, because that means that my answer is correct. So 7 minus 0, I hope that that is not greater than or equal, I'll put a line through it, not greater than or equal to 3 times 0 plus 10. So is 7 not greater than or equal to 10? And that it is not. So okay, so there you go. Now we're increasing our confidence. Okay, so what was the gotcha that I was talking about that you had to worry about? Okay, so solving inequalities is always the same as solving equations, except when you multiply and divide by a negative number. Okay, minus x is greater than 4. Okay, now if you just naively multiply both sides by minus 1, you would think that the answer is x is greater than minus 4. Okay, let's try to check that. If I plug in 0 into the original equation, that does not work. So 0 is not bigger than minus 4. The problem is that when you multiply or divide by a minus, you have to remember to switch the direction of the inequality. So let's do it one more time, remembering that caveat. So multiply both sides by minus 1. Okay, so we write the pieces for both sides. Now I'm going to flip the direction of the inequality. Instead of a greater than, less than. See that? Okay, so let's see if that works. We know 0 does not work, so we've checked that. Let's check if, let's say, minus 5. So I'm going to plug minus 5 into the original up there, and 5 is bigger than 4, so yep. Okay, so that's the deal. That's how you solve those. Okay, now multivariable forms. In other words, what if you had more than one variable in an equation? Well, that's nothing to get worried about. You just treat the other variables the same way you would numbers. Okay, like for example, suppose I told you to solve for x. Okay, if y was a number, you would move it to the other side, right? And then you'd have x equals something. Okay, well, just work with that idea. So let's move y to the other side. It's not a number, but we can still use our same skills. So these guys, when you subtract y from both sides, these guys kill each other. So x is 4 minus y, and so your answer will be in terms, if let's say you wanted to solve for x, your answer will be in terms of the other variables because we don't know what those values are as well. Okay, but if we did, if we knew what y was, we could immediately use this answer to figure out what x was. Okay, this is the original red equation. The both values have to add to 4. Okay, let's say that y was equal to 0. Okay, plug in into the answer 4 minus 0, so x is 4. So clearly 4 plus 0 is equal to 4. Let's say we picked 1 for y. Then 4 minus 1 would give 3. Okay, so clear, you can see that no matter what you choose for y, the answer in black will always give you something where the x and y add up to 4. That's what it's supposed to do. Okay, and so please, there's nothing mysterious, there's nothing extra here to really learn. You just treat other variables like numbers. Okay, you move them all around the same way. Okay, now there is one thing you have to be careful of. Okay, you are allowed to divide both sides of an equation by everything except 0. We already knew that, right? Now, when you divide by a variable, you don't know if that variable is 0, do you? Okay, so you have to either avoid dividing by unknown variables, or somebody has to tell you, yes, you can assume that this variable is not 0. Okay, but something has to give. You can't accidentally divide by 0, or there's going to be trouble. Okay, let me give you maybe one inequality example, and you try to solve it, and then we'll finish. So can you solve this one for, let's say, how about solving it for z? Take a minute to do that right now. And I will finish it up by doing it right now. So I would, let's see, maybe move everything to the other side with some careful subtractions. So that, let's see, then we blow stuff up, which we love. Okay, so we get to the blue, yes. Now, by the way, the next thing I'm going to do, and that's that I change it to an equal sign. I don't want to do that. Now, I could avoid dividing by a negative by doing this. Let me just do it both ways to show you. I could, at this point, let's see. Well, you could move the 4z, you could add 4z to both sides, right? And if you did that, then you all of a sudden the coefficient on the right side, you'd have a positive 4z on the right side, right? And then you wouldn't have to switch the direction of the inequality. Go ahead and solve it that way if you like, but for the sake of giving another example of the issue with negatives, I'm going to do it a different way. I'm going to divide by a negative 4, and this will give you the same exact answer. You can, again, do it both ways if you're skeptical to check. Okay, so I divide by negative 4. I'm going to switch the direction of the sign, and then on the right side, I can go ahead and change this fraction, change all the minuses to a positive. I'm multiplying top and bottom by -1. All right, so there you have it.